Today is August the 24th, 2020, 6:39 p.m. Central Standard. This is another article from ScienceAlert.com. The article is from the Nature section, and the title is Geologists Confirm Bizarre Boomerang Earthquake Deep Beneath the Atlantic Ocean by Peter Dockrell, published on the 11th of August 2020. First, let's zoom into the photo. So just here beneath the photo, we see reconstructed image of the Romanche fracture zone. Hicks, A.L., Nature Geoscience 2020. This reminds me of digital imaging that I saw of the Mariana Trench a while back. Let's zoom in. It looks very clear. I can see the landscape really well. Interesting. Alright, let's see. Earthquakes come and go, often leaving a trail of devastation in their wake. What they don't usually do, thankfully, is turn around immediately and come back for another pass. Except, it looks like they can, in exceedingly rare circumstances. In a new study, scientists have found evidence of an unusual and virtually unprecedented Boomerang earthquake that shook the deep seabed underneath the Atlantic Ocean in 2016. This earthquake, termed a back-propagating super shear rupture, took place along the Romanche fracture zone, which lies near the equator, roughly midway between the east coast of Brazil and the west coast of Africa. The fracture zone, a fault running for about 900 kilometers between the South American and African tectonic plates, adjacent to the Mid-Atlantic Ridge, produced a 7.1 magnitude earthquake in August 2016, which was detected by undersea seismometers in the region, as well as by distant monitoring stations. Analysis of the signals reveals this was no ordinary quake, but a strange trembler that went one way before turning around and coming back for more, and with a significant increase in speed, no less. While scientists have found that such a reversing rupture mechanism is possible from theoretical models, our new study provides some of the clearest evidence for the enigmatic mechanism occurring in a real fault, says lead researcher and seismologist Stephen Hicks from Imperial College London. According to analysis of the seismic data, the 2016 quake had two distinct phases. First, the rupture propagated upward and eastward in the direction of a weak spot where the fracture zone meets the Mid-Atlantic Ridge. Then, in a sudden about-face, an unusual back propagation westwards took place, with the tremors heading back to the center of the fault and at much accelerated super shear speeds of up to 6 kilometers per second or 3.7 miles per second. Even though the fault structure seemed simple, the way the earthquake grew was not, and this was completely opposite to how we expected the earthquake to look before we started to analyze the data, Hicks says. Via GIPHY. While the team's explanations for how this boomerang turned around remain speculative for now, the researchers hypothesize that the first deep phase of the quake released sufficient fracture energy to initiate the rupture reversal in the shallower, westerly underwater terrain. Either both fault patches were sufficiently pre-seismically stressed to promote seismogenic failure, or the deeper SE1 rupture instantaneously increased the static stress, immediately causing the shallow SE2 portion of the fault to fail, the authors explain in their paper. While backwards propagating earthquakes have been studied by seismologists before, up until now, the evidence for them is sparse, with the phenomenon mostly seen in theoretical modeling. To detect one like this in the real world, out in the middle of the ocean, is a first of its kind type of event, let alone a boomerang that came back at super sheer velocity. To the best of my knowledge, this is the first time it has been reported. Geophysicist Yoshihiro Kaneko from GNS Science in New Zealand, who was not part of the study team, told National Geographic. The findings are reported in Nature Geoscience. That's interesting. That's very interesting, actually. And I'm seeing something below here that says increase in the incidence of acute coronary syndrome after the 2011 East Japan natural disaster, concordance with sequential quake shocks. I might do something about that later, or maybe not. So back to this article. I find that very interesting. So basically, an earthquake is occurring and going out eastward and then turning right back around and coming back to where it started. Wow. And that's happening in the ocean at this time. If that happens on land, that's going to be so much damage done. That's probably where it's coming. So I wouldn't be surprised if earthquakes coming to the United States and other places now come and then go back to where they came from, which would probably do twice as much damage or even more. I thought this was an interesting article. You guys give me feedback. Let me know if you like it or what you thought. All right, have a great day.